Hoffman's mustard oil test. Hoffman's mustard oil test only for primary amines, to detect only primary amines, not for secondary and tertiary. Then how can we detect secondary and tertiary? By using other tests. Hoffman's mustard oil test is only used for primary detection of primary amines. Okay. Only for 1 degree amines, to detect 1 degree amines. Amine, primary, secondary and tertiary. I am giving just flow chart. Primary amines when treated with the CS2, carbon disulfide. First we will get N-alkyl dithionate, N-alkyl dithionate is formed, which is when treated with the HgCl2, alkyl isothiocyanate and HGS, black PPT, black PPT is formed. This is isothiocyanate. It is having mustard oil smell. N-alkyl dithionate, after treating N-alkyl dithionate with HgCl2, mustard oil smell is formed or black color precipitate formation takes place, indicates presence of primary amine. Secondary amines when treated with CS2, N-carmine dialkyl dithionate is formed, but it is when treated with HgCl2, no reaction. So mustard oil smell is not observed, and the secondary amine do not react with the CS2. So this is particularly used to detect a primary amine only for primary amine. Okay. Which amine produce mustard oil smell? Primary amine. That is the question. Clear? Mustard oil test is used for the detection of primary amines only. We use 3 reagents for the distinguishing. First one NaNO2 plus HCl, second one Hinsberg reagent, third one mustard oil test. These 3 reagents we can use for the distinguishing. Okay. Next, Hoffman's exhaustive methylation. Next property, Hoffman's exhaustive methylation. Exhaustive methylation means doing excessive methylation. Exhaustive methylation. First important point is Hoffman's product will predominate. What is Hoffman's product? In the alkyl halides chemical properties we did this. Hoffman's product. You know Hoffman's. What is Hoffman's product? You know already. Less stable. Yeah. Less substituted alkene. Less stable alkene. Hoffman's product formation takes place. Hoffman's product means less substituted alkene. Hoffman's product formation takes place. So in the PDF I given mechanism, but you no need to follow the mechanism. See the shortcut here. CH3. This is 2-butanamide, CH3 iodine, excess followed by treatment with cell base. Then we will get 1 degree not 1 degree, less substituted alkene, sir. Less substituted alkene. How to identify less substituted and more substituted? How to identify less and more substituted? Alpha hydrogens. Let us draw this in other form. CH3, CH2, CH double bond CH2. This position is alpha position. Alpha. How many alpha hydrogens are present? Only 2 alpha hydrogens are present. So 1 butene is less substituted alkene. If we take 2 butenes, how many alpha hydrogens are present? This is alpha carbon, this is alpha carbon. What is alpha carbon? Carbon which is next to double bond. Is called alpha carbon. We have 3 alpha and 3 alpha. Total how many? 6 alpha. Okay. So in the Hoffman's exhaust 2 methylation, we will get a Hoffman's product as major product. Less substituted alkene as major product. In generally, Sage-Jeff's product is major one. Highly substituted alkene is the major one. But the speciality of Hoffman's exhaust methylation is we'll get a less substituted alkene. Okay, right. See the mechanism, shortcut mechanism for this. CH3, CH2, CH. Write this CH3 like this. Remove ammonia. Minus NH3. This is shortcut mechanism. We will get double bond at this position. Okay. Hoffman's exhaust 2 methylation. Major product is less substituted alkene. Less substituted alkene is the major product. Okay. Right. For NEET level, this is enough sufficient. This example. What is its name? 1, 2, 3, 4. 2-butanamide. But important point is less substituted alkene is the major product in the Hoffman's exhaust 2 methylation. Exhaust 2 methylation means doing excess of methylation. We will add methyl groups on the nitrogen atom. That is excessive methylation. Okay. For JE level, we will go with the mechanisms and different examples. For NEET level, just basic level information is sufficient. Okay. Right. Next, acetylation and benzoylation. Tell me. But aliphatic we didn't. For aromatic we completed. Acetylation. What is acetylation? In the aniline we did. What is acetylation? Introduction of acetyl group. Introduction of acetyl group is called as acetylation. What is acetyl group? CH3 C double bond O group. This group is acetyl group. Acetyl. CH3C double bond. Acetyl group also called as acetyl, or another name is acyl, acylation, acetylation. All are same one, right? Now reagents for the acetylation. Reagents. What are the reagents for acetylations? Acetyl chloride in the presence of pyridine, or AC2O, acetic anhydride. We can use two reagents to do acetylation. AC2O, acetic anhydride. Sometimes we will get a structure also. Acetic anhydride structure, CH3CO. Both are same. This is one AC, this is one AC. AC2. In the middle, oxygen. Clear? One AC. AC means acetyl. This one. Okay? Middle, oxygen. The role of AC2O is to introduce acetyl group. Acetyl group. So let us see one example. In the presence of solvent pyridine, the product is RNH C double bond O CH3. N substituted amide, and the nitrogen substitution is there, so we can call it as N substituted amide. N substituted amide. I think this is the question in your weekend exam, last weekend exam. N substituted amide. Okay. See the mechanism for this. Direct reaction mechanism is just the removal of H and Cl only in the presence of pyridine. Remove hydrogen and chlorine. So you will get RNH C double bond O CH3. Okay. You see this example. CH3 C NaOH plus Br2. See one conversion. What is the product? What is the product? What is the name of the reaction? CH3NH2. In the last class only, you did amines. Preparations of amines. Hoffman bromamide reaction. H and Cl both are eliminated here. So CH3 NH C double bond O CH3. Conversion type. What is the mechanism? This chlorine and hydrogen both are eliminated. This Cl will join to nitrogen. Got it? This is acetylation only in the presence of pyridine solvent. Pyridine. Two hydrogens are there. One hydrogen and chlorine both are eliminated. This group joins to nitrogen. Okay. Conversion type questions. Acetylation. Next, benzoylation. What is benzoylation? Introduction of benzoyl group. Benzoyl group is Cl C double bond O. Benzoyl chloride. This is benzoyl group. Reagent is benzoyl chloride. This is benzoyl group. Benzoyl group. Reagent benzoyl chloride. Reagent for benzoylation is benzoyl chloride. Okay. Take one example. CH3NH2. Same solvent is pyridine only. Hydrogen and Cl both are eliminated. This hydrogen and chlorine both are eliminated, and both will join together. In the presence of Shorten-Bowman is this different. Shorten-Bowman reaction. Next subtopic is there, benzene diazonium chloride. Benzene diazonium chloride. Benzene diazonium chloride. Benzene diazonium salt. Benzene diazonium chloride. How to get benzene diazonium chloride? Aniline chemical property. NaNO2 plus HCl. At 0 to 5 degrees centigrade. Then we will get the benzene diazonium chloride. Benzene diazonium salt is formed. Benzene diazonium salt. Preparation of benzene diazonium salt from aniline to benzene diazonium salt is carried by using NaNO2 plus HCl, or we can write like this also, HNO2, nitrous acid. When we combine these two, we will get nitrous acid. So we can use HNO2 also. Okay. Benzene diazonium chloride preparation, and we know how to get aniline also. How to get aniline from nitrobenzene? Tell me. How to get aniline? What is the reagent to get aniline from nitrobenzene? Tin plus HCl. So conversion type questions. How to get NO2? How to get NO2? NO2 from benzene. Concentrated HNO3 nitration mixture. Concentrated HNO3 plus H2SO4. See conversions. Benzene to nitrobenzene. Nitrobenzene to aniline. Aniline to benzene diazonium chloride. Okay. Very important conversion. First, we have to prepare nitrobenzene from benzene. Nitrobenzene from benzene. How to prepare? By adding nitration mixture, concentrated HNO3 plus H2SO4, or we can use fuming HNO3 also. Fuming HNO3 alone can be used to get nitrobenzene from the benzene. Very important. Okay. Once look at this overall conversion. Once again, remember all of you, benzene to nitrobenzene is prepared by adding nitration mixture to benzene. Then we'll get nitrobenzene. Nitrobenzene when reduced with tin plus HCl will get aniline. Aniline when treated with NaNO2 plus HCl, benzene diazonium chloride is formed. Okay. Look at this. Benzene. Concentrated HNO3 plus H2SO4 will get A. A when treated with the tin plus HCl. B is formed. B when treated with NaNO2 plus HCl at 0 to 5 degrees centigrade produce C. What is C? That is the question, conversion type questions. Okay, right. Benzene when treated with nitration mixture, what is the role of this reagent? What is the role of this reagent? It releases NO2 plus electrophile. So A is equal to, A is nitrobenzene. A is nitrobenzene. Nitrobenzene when treated with SN plus HCl, aniline is formed. So B is aniline. Aniline when treated with NaNO2 plus HCl will get a benzene diazonium chloride. Okay. So conversions also very important. Clear? You know already aniline preparation in the last class. I given one extra nitrobenzene preparation. Very easy. Take benzene, add concentrated HNO3 plus H2SO4. Okay. I'll send this PDF also. Right. Coming to the properties of benzene diazonium chloride. Benzene diazonium salt. You know these properties. In the first chapter, we did preparations of aryl halides. Yes, Sandmeyer, Gutterman. Okay, Scheinman's reaction. See the properties of benzene diazonium salt. Let us take in the middle. What is Sandmeyer reaction? CuX followed by HX. Or you can take Cu to Cl2 or Cu to X2. Cu to X2 HX. In place of X is equal to chlorine, bromine, iodine, astatine, cyanide. We can prepare chlorobenzene and bromobenzene only in the Sandmeyer reaction. What is the product? First chapter, aryl halides preparation. You will get chlorobenzene or you will get a bromobenzene. Chlorobenzene or bromobenzene. Okay? Right. What is the name of this reaction? Sandmeyer reaction. Sandmeyer reaction. A repeated reaction. This is. Next, Gutterman reaction. Gutterman. In Gutterman reaction, we use only copper powder, where X is equal to chlorine, bromine, cyanide. Here also chlorobenzene and bromobenzene are prepared. Name Gutterman reaction. Very important point I am giving. More yield is observed in the Sandmeyer reaction compared to Gutterman reaction. Sometimes you will get statement type questions. In Sandmeyer reaction, amount of product is more. For example, we can prepare chlorobenzene by this method, we can prepare chlorobenzene by this method, right? But more amount of chlorobenzene is formed in Sandmeyer reaction. Statement type questions, reason assertion type questions. Okay, what is the reason for that? See, CuX means CuCl followed by HCl. CuCl followed by HCl. Copper is directly attached to halogen, CuX. So release of halogen is very easy. Okay, and rate also very fast. Clear? But here first X will come from HCl and it should react with the copper. So that is the lengthy process. Here directly copper is attached to halogen. So liberation is easy. Liberation is easy. That's why yield is more in Sandmeyer reaction. In Sandmeyer reaction, more yield is formed because halogen is directly connected to copper, so release is easy. But in the second case, first halogen will come from the HCl and it should attach with the copper. That is a late process. That's why yield is less. Yield is less. Right? So tell me finally, in Sandmeyer and Gutterman, in which reaction will get good yield? Sandmeyer reaction will get good yield. More amount of product. Good yield means more amount of product. Okay? Right. Sorry. Chlorine and iodine. See, iodine is a large size atom. So CuI is unstable compound. CuI is unstable compound. Okay. And the reactions involving chlorine is exothermic. That's why we do not prefer these two. Iodine size is larger. It cannot fit with copper. Okay, that is the reason. And reactions involving fluorine are exothermic reactions. That's why these two methods are not used for the iodination and the fluorination. So we adopt separate reactions. I am giving that only next. Okay. Potassium iodide. Potassium iodide. Potassium size is larger compared to copper. That's why iodine can fit with the potassium. Okay. Iodobenzene. For iodobenzene we use Ki, potassium iodide. Potassium iodide. HbF4. HbF4 delta. Yes. Fluorobenzene. What is the name of the reaction? Siemens reaction. Siemens reaction. This is over already in the first chapter on Siemens reaction, fluorination. Okay. So these are first chapter reactions only. First chapter reactions only. Now let us see different reactions, new reactions. In first chapter, we discussed about these only because there we have to prepare aryl halides. Clear? Right. Next. When benzene diazonium chloride treated with water, phenol is formed. Phenol is formed. Okay. And benzene diazonium chloride treated with H3PO2. H3PO2 is a good reducing agent. Benzene is formed. Important. Phenol preparation and benzene preparation. H3PO2. Sn plus HCl. This is also reduction. Tin plus HCl. We'll get phenyl hydrazine. These are some additional reactions. Okay, along with that regular examples, some additional reactions are given. HF BF3 or HBF4 followed by NaNO2 in the presence of copper plus one salt, copper plus salts, we will get nitrobenzene. This is also important reaction. HF or BF3 or HBF4 in the presence of NaNO2 followed by copper plus salt. These are constructed only, there is no proper mechanism, we have to by heart. Okay, how to by heart, and remember first two are easy because phenol is a famous compound, so you can remember that we did this reaction in the phenol chapter. and second one is benzene preparation, so we can remember. So this is new and this is new, these two are new, we have to learn these two. Okay, right, coming to the another properties, just tell me. Okay, next, coupling reactions of benzene diazonium chloride. Coupling reactions. Sorry. Next, coupling reactions. Coupling reactions of benzene diazonium chloride. Benzene diazonium chloride couples with phenol aniline to produce azo compounds, colored compounds. So we know hair dyes, for holy festival we use dyes that are prepared by this reaction only. Azo dyes. Azo dyes is colored compounds. Azo dyes, hair dyes, dyes used in the holy festival, or some other colors are prepared by this coupling reaction only. Coupling means attaching with some other molecule, right? Okay, let's see. First one, coupling with the aniline. Coupling with aniline. Aniline. N2 plus and Cl negative. What is the nature of NH2 group? NH2 is which group? Plus M group or minus M group? NH2 group is which group? Plus M. Electron donating group. Electron donating group. Electron donating group increase electron density in which positions? Ortho and para positions, right? So NH2 group is a activating group, ortho para directing group, right? So in which positions we have a negative charge? In ortho and para positions. Nitrogen is having positive charge, it needs electrons. At this position electron density is present, right? Here also electron density is present, but this place is ortho to NH2. Due to some repulsions, this positive charge prefer this site only, not this site. Okay, so nitrogen attacks this site. Why? Because here some obstacle is there, some crowding. That's why nitrogen prefers para position only. So coupling will take place in the para position. Through para position, coupling both will join together. In the coupling reaction, what is the role of benzene diazonium chloride? It acts as dash, electrophile or nucleophile. Positively charged species are called what? Electrophiles. Electrophile. This is nucleophile. Nucleophile. And a very, very important point, this reaction is carried in a slightly acidic medium. Carried out in slightly acidic medium. Slightly acidic medium. Very, very, very easy to remember. You tell me, benzene diazonium chloride is coupling with aniline, right? Aniline is base or acid? Aniline is base or acid? Aniline is base or acid? Base. That's why prefer slightly opposite. For example, you are taking here phenol. Next example with phenol only. Phenol is acid. So we take a basic medium, slightly basic, opposite medium, and pH is equal to 5 to 7. Slightly acid, na? pH value is also important. Okay. Benzene diazonium chloride couples with aniline at pH 5 to 7. Slightly acidic. Right. Now let us see the product. Two nitrogen atoms are there. NH2 diazonium salt, both are joined with N double bond N. This is called azo group. Azo link. N double bond N link is called azo link. Right, this is a colored compound. You tell me, aniline, what is the first letter? A. Yellow, what is the first letter? Y. But pronunciation, yellow, not yellow, aniline. Remember like that. So when we take aniline, which color is formed? Yellow color. Aniline, yellow, not yellow. Just read it as yellow. ALLO, yellow color. Okay. Azo link. Yellow color dye is formed. Yellow dye. Sometimes colors also will come. With aniline, yellow color is formed. And where nitrogen link is formed? In para. Okay. In phenol chemical properties, we did this. Phenol. Same reaction, everything is same. Only nucleophile will change. N2 plus and Cl negative. OH is the electron donating group. It increases electron density at ortho and para positions. And phenol is acid. So reaction takes place in slightly basic medium. We have to mention that reaction takes place in slightly basic at pH 7 to 10, slightly basic. Because to make a neutral solution, this is a salt like compound, N2 plus and Cl negative. So if we use slightly acidic medium, here also we'll get some salt like compound. So salt solution, reactivity will be more. That is the reason. Okay. This is N2 plus Cl minus means salt only, na? What is this? Acid. What you are taking? Yes. So here also you will get some salt type. This is also some salt type. So reaction will be very fast. Clear? That's why we are using particularly basic medium. So how to remember whether basic or acidic medium? By using opposite concept. When we take acid, use basic medium. When we take base, use acidic medium. Slightly. Right. Same reaction. Nitrogen joins to phenol at the para position. What is the color of the compound? You have any idea? In phenols, orange. Phenol, O, orange. Phenol. Okay, orange color. Orange color dye is formed. Orange dye. Orange dye. Now, one important question to you. To increase the reactivity of coupling reaction, what we have to do? We have to attach which type of groups to benzene diazonium chloride. You know, benzene diazonium chloride is electrophile. Benzene diazonium chloride is electrophile. So how to increase this its electrophilicity? Yes, exactly, by attaching electron withdrawing group. I'll explain clearly. Look at this. Once observe the magnitude of the charge. I wrote small positive charge. Take any compound here, like aniline or any other compound. That should contain donating. That is the condition. Let us consider its rate as R1, rate or speed as R1. It attaches to para position. No. See the difference. Sorry. NO2, strong withdrawing group, is attached. Large positive, because NO2 is withdrawing group. Withdraw electrons from the ring withdraw electrons from the nitrogen. Nitrogen is already deficient only. Nitrogen is having positive. Again this NO2 is taking electrons further. So what happens to its deficiency? Deficiency further increased. So large positive. So it attacks easily. Clear? Because here negative is present or not in ortho and para. So this large positive attacks negative readily. So which rate is more? R2. R2 is greater than R1. So final conclusion, by adding or by attaching -M groups to benzene diazonium chloride, we can increase the rate of coupling reaction. Very, very important. Okay.